Assalamualaikum and good evening. My name is Muhammad Amar Amiruddin bin Khalid from Group C5 from Thursday class session. For this mini project of IC design, we were tasked to create a layout and schematic that have a minimum of 12 transistors. So in order to achieve the 12 minimum transistor, we decided to go with 2-to-1 multiplexer. The reason we decided to go with 2-to-1 multiplexer because it is a very relevant electronic that is being used still in this day. So we would like to learn how to make the schematic layout of the 2-to-1 multiplexer. Okay. From the schematic, we are seen there are about 4 NAND gates that being used to create the output of Y. Before I talk about schematic, the output of the Boolean expression of the NAND of 2-to-1 multiplexer is equals to Y equals to I0 S bar plus with I1 and S. So in order to get the output of Y, the desirable schematic must be achieved like this. And then to verify whether our schematic is correct or not, we select a table from the internet to check the output of our schematic is correct or not. And then after creating the schematic, we will run the waveform using Zelga, and then the output waveform is shown. So I will show an example of 2 to 3 waveform to verify whether its output and input is the same as the shown in the internet. So firstly, we see at the first period, which is the I1 is 0, I0 is 0, and the select is 0, and then the output is Y equals to 0, equals to 1. So 1, 1, 1, and 1. As seen in the last row of the truth table for the Boolean expression, we can see that the input and the output is the same in the waveform. And then moving on, we will see the last row, which is 0, 0, 0, and the output is 0. So in the I1 is 0, the I0 is 0, the select is 0, and the output from all of this is 0. And then to check whether this waveform is true or not, we will refer to the truth table that we have created and seen in the internet. So the first row of the truth table is 0, 0, 0, and the output is 0, which is the same as the waveform. Okay, that's all from my part to see whether the waveform is correct and derived from the schematic.
Hi, my name is Muhammad Arif Muiz bin Muhammad Syamsul, and I will present about the Boolean equation and the layout part. So, as for this layout, we will use the equation of Y equals to S bar I0 plus S I1. To obtain the S bar I0, we pick from the S input. Then we go through the inverter to get the S bar. After it went to the S bar, it goes to the inverter, it will engage with I0, then it can obtain the S bar I0. As for the S I1, the S and I1 input will go through the NAND gate, then it went to another NAND gate that is intersect with the S bar I0 NAND gate. After it intersect, both of these input will NAND together and it can obtain the y output that we have declared, which is equal to y equals to f bar I naught plus f I1. So that's all from my part. Thank you.
Assalamualaikum and hi. My name is Muhammad Nabil Irfan bin Muhammad Amin. Now I will present about the analysis of layout. There are two methods that we use to verify the layout and schematic, which is DRC and LBS. Okay, both of these methods are used to check the parameter and connection. DRC means design rule check. DRC process is to check the element parameter whether it is achieved or not. If the parameter are not achieved, then there will be an error. The error will be show where it's happened and easy for us to fix it. The next method is LVS. LVS means layout versus schematic. This process is to check whether the layout and schematic have the same configuration or not. That will be easier for us to there will be error if the connection of input and output is wrongly inserted in layout. Okay, for our project, after completing the layout of schematic of 2 to 2 multiplexer, we then move to the next step, which is to run the DRC. Okay, the result of DRC show that there is no error, so that the layout follow the rule and spacing of DRC. Okay, lastly, we run the LVS to check whether there is a short circuit or of unconnected net. Okay, also the LVS show the number of transmission of port net and total intenses. Okay, the objective of this mini project is to create a layout that have 12 resistors. As seen, the LVS, the total of transistor that we use is in the layout is 17. Okay, thus we have achieved the objective of the mini project. So that's all for our mini project. Thank you.